So we are going to talk about what is the domain of a function. In the previous video, we defined what is the domain of a function. So we considered some examples and found their domains. But we are also going to look at further examples of the functions and how to find their domains. So let's look at an example. We have a function. Let's say y is equal to 10x. It's a trigonometric function and we have to find all allowable x's, which will then call domain of this function y is equal to 10x. In this case, we know that if, let's say, we plug x equal to 45, so and 45 is an angle, so when we plug x is equal to 45, we get y is equal to 1045, and you can use the calculator to find 1045, which is 1. So 45 is the part of the domain because it is allowable in the sense that when we plug 45 in this trigonometric function, we got the output as the real number. So 45 is going to be the part of the domain. But when we plug x is equal to 90, we will see that y is equal to 1090, and 1090 is something not defined, which is infinity. So it means that 90 is not allowed to be a part of the domain because it did not give the output as the real number. So 90 is not. Now if we plug x is equal to 270, we will see that y again is 10 270. You can use your calculator to see your answer. It is infinity. So what we have seen here is that the domain of this function are all real numbers except for multiples of 90. 90 could be written as pi by 2 and n is for the multiples of pi by 2, which is 90, and here you will see that n is an odd number, odd integer, which is like 1 3 5 7. So this is the domain of this function y is equal to 10x. Let's look at another important function and we will try to find its domain. If we have y is equal to x plus 2, now we can see that the allowable x's in a square root involving function are all positive numbers inside the square root. Or we can just look at, first of all, here y is equal to square root x, and if I ask you what is the domain, and we discussed this in the previous video as well, so here under the square root we can never have a negative number, right? So here the simplest way to write the domain of a function that involves the square root is whatever is inside the square root. So here inside the square root is x. Whatever is inside the square root, it should always be greater or equal to 0. That's the first step of finding the domain of a function that involves the square root. So whatever is inside, in this case the inside thing was was x, so it should be greater than equal to or equal to 0. As long as x is greater or equal to 0, whatever we plug from x greater or equal to 0 here inside the square root, we will get for y a real number as an output. Back to this question, y is equal to x plus 2 square root, we have to find its domain. So again, to find the domain of such function, we will say that whatever is inside the square root, at the moment it is x plus 2. X plus 2, whatever is inside the square root, it should be greater or equal to 0. This whole thing should be greater or equal to 0 because x plus 2, as long as this whole thing is greater or equal to 0, we could put them back inside the square root, right? So that's the first step of the domain. Wherever the square root function is involved, whatever is inside the square root, it should be greater or equal to 0, and then we can write it as x should be greater or equal to minus 2. We take 2 over there with the change of the sign. So this is the domain of this function, we say that this is the domain in the form of an inequality, but we can also highlight this domain on the real number, just like what we did in the previous video. So this is the real number line. So all this is how to read this. I'm going to read it as all numbers greater or equal to -2. So first of all, I will mark -2 here. So what are the domain? All x's greater or equal to -2, or we can read it as all numbers greater or equal to -2. So all numbers greater or equal to -2, first you have highlighted -2, and the numbers greater or equal to -2 are on the right of -2. So all these numbers, right? And or equal to -2, since -2 could also be included, so I'm just putting a bold dot just to indicate that this -2 is included. Now let's write this part in the form of an interval. So -2 is included, that is why n close bracket. All the numbers starting from -2 all the way to positive infinity, and on infinity and minus infinity you put an open bracket like a parenthesis. So domain could be put in the form of the interval like this. It could be highlighted on a real number line, and you could put the domain in the form of an interval like this. Let's very quickly look at this similar example. Let's say you have to find the domain of x minus 7 square root. The simplest way of finding the domain of these functions, what you do is you simply write whatever is inside the square root. This time inside the square root we have x minus 7. This is greater or equal to 0. It should be greater or equal to 0 inside the square root. It will give you a positive number, and we are good then. And this could be written as x is greater or equal to 7. Then that's the domain. We can highlight this on a real number line from minus infinity to infinity. In between we have 0, but the domain is all this is how I'm going to read this: all numbers greater or equal to 7. So first I'll mark 7 here. All numbers greater or equal to 7 are here. Let's put this in the form of the interval. It's the highlighted part is starting from 7, ending at infinity, open bracket at infinity. And what about 7? Is it included? So yes, back to this, x greater or equal to 7. So it means 7 could be a part of the domain. Again, when we put x is equal to 7, it gives us a real number y as 0. And as long as any number x that gives us a real number, we could include that x in the domain. So domain here is x is greater or equal to 7, or highlighted part, or this is the domain in the form of an interval. So this is how we find the domain of the functions, all allowable x's. In the next video, we are going to talk about different operations on functions. Operations like you add numbers, multiply numbers, divide numbers, subtract numbers. The same way we can do these operations on the functions, and once we have done operations on these functions, we can find the domains of these functions as well. This is what we are going to discuss in the next video. Thanks.